Hello everyone, welcome to Learn Overflow. In this video, I will discuss about the strings and the tuple data types of Rust. In our last video, if you remember, we discussed about the cat data type and I told you how cat is stored in a 21-bit integer type format and that is padded to a 32-bit wide. So now it's time for string and tuple. We'll see how this works. So in Rust, there are basically uh, like the one type of string. So Rust basically has many types of string, but we usually work with two different types. So if you're interested to know all the other types of string, then it's better to go into the Rust documentation. Here you will found there are few types, like one is str, another one is string. The others that we can use this like 0s string, 0s str, c string, and cstr. So these are the ways you can experiment and learn more about all these types and their uses here. But I will discuss first about the str type, like the str type. Okay, so first to discuss about the str type. So this is also known as the string slice, and this is a view into the string data. Okay. Now, most of the time we refer to these types by using reference style syntax, and that we do by using like we precede this with an ampersand. So for now, you can think that like ampersand str as a pointer to an immutable string data. So string literals are all of type ampersand str. Okay, so that's how the first type of string is defined in Rust. Now, such string literals are convenient to use in introductory Rust examples, the ones which I am showing you now, are the introductory ones if you're doing. So this kind of string literals are convenient to use. But they aren't suitable for every situation where we might want to use them. How like you can say that not every string can be known at the compile time, right? As an example, if I just say like when a user interacts with the program during the runtime and sends a string or sends a text via terminal, like you are trying to give a input, okay, or you are trying to just give a like send a data to the program during the running time. So in that case, the strings can, like the strings, the length of the string or every string is not known to you, like. So for this kind of scenarios, Rust has a second string type named, we call like a second string type named string. That's a capital string string. So this type is allocated on the heap, and when you use this string type, okay, this string type, the length of the string, that is the number of characters, does not need to be known before it is compiled. Okay, so that's the basic difference. When you're using this, you shouldn't know the exact like the length. Like before compilation, it is not necessary for you to know the length of the string, but for here, you need to know the length of the string. Okay, and also we remember we use this ampersand str as a pointer to immutable string data. So that is str. I'll show you an example. I'll show you how this ampersand and ampersand str and str actually differs. So str is the type and ampersand str you can think of a pointer to the immutable string data. Okay, so string literals are of the type ampersand str. Now, you might think, okay, what's the need for these two types? Or I have shown you that there are other few other types of string formats. in Rust as well. So you may think like, why all this? Okay, so basically Rust have more than two types of string, and they it's coming from the concept of garbage collection. I'll tell you how. If you are familiar with garbage collected languages, you might be wondering why Rust has two strings or more than two types of strings. So strings are extremely complex data types. Most language use their garbage collectors to gloss over this complexity. Okay, but Rust, as a systems language, exposes some of the inherent complexity of string. With this added complexity comes a very fine-grained amount of control over how the memory is used in your program. So for this purpose, we use this various types of like the strings uh, in Rust. Okay, remember, just to have a fine-grained amount of control over how a memory is used in our program. That's the basic purpose. Okay, so probably you won't get a full idea of the difference between these two types, string and ampersand str. So for that, in upcoming next videos, somewhere in the next video, I will tell you about the Rust ownership and the borrowing system. So in that, it will be clear to you how this what is the basic difference between this like the full you can gain a full idea of the difference in between this string types. Okay, so until then, you can think that this string data type as the text data that can change as the program runs. Okay, so for you, it might not be known to you what's the length of the string, what's the characters of the string. So this can be just changeable, like this string format. This can be changeable for you. And the ampersand str, this one, this ampersand str references are immutable views into the text data that don't change as the program runs. So once you create this type of variable, it won't change as the program keeps on running. Okay, so that's a simple difference. You just keep in mind as of now. I will discuss full details into this in while I will discuss the Rust ownership and borrowing system in somewhere in the next videos. Okay, so let me take an example. Okay, so here I just wrote the example for you. In the following example, you can see how you can use the char. You can use the char data type, as well as you can see how you can use the string data type, that's the ampersand str. And obviously there's use of another one where I didn't mention which data type is this. Okay, let's go into this step by step. The first two, okay, the first two here you see the character variables are declared as char. Okay, char annotation syntax, and the value are specified by using single quotation mark. Okay, look, this is a single quotation mark, and that's how we declared its value. Okay, now for char, this is important that you declare with a single quotation, and whenever there's a string coming in, you need to declare with a double quotation mark. So there's a small difference between char and string. And I remember I probably have discussed this in my last video as well. So the third one, okay, the third character that you see here is a variable. This is a character variable, and this is declared and bound to a single image. And if you see, this is not a like the normal thing that you can type in your keyboard, right? This is an emoji. And what is this? This is an image, like a small image. The variable that you copy from internet, that's the one, that's a small image. Okay, and this particular smiley face is the variable name that is bound to a single image. That's the single image we have here. Okay. So for this variable, we let the compiler infer the data type. Here, we didn't specify what's the data type. We let the compiler to just infer whatever data type it is. Now, next thing, there you can see two strings. Okay, I have used here two strings, and these two string variables are declared and bound to their respective values. One's this and one is this. So we bounded these two variables into their respective values. Then this, like, one of the string variable is declared with ampersand str annotation syntax and to specify its data type. Okay, so we one of it we declare with ampersand str. So the data type of the other variable is left unspecified, and the compiler will automatically infer the data type of the variable based on the context. Okay, so that's how it would work. And also notice I have given an extra space in like the included an extra space within the string one. Okay, so that like at the end, so that it does something. And so space is also within the string. Okay, so if I just run this example and see how this happens. Okay, so just let's run this example and see, look what happens here. So first it says the smiley face should be printed. Okay, so smiley face is printed here. Then it says smiley face space is a space then character one. Then what is this character one? Character one is capital S. Okay, smiley face is a space. So up to this much is done before. Then character one is this small capital S that's printed. Then we printed string one. So string one was this one, including that extra space. Okay, this space. So with string here one, we printed this much, and then comes character 2. Character 2 is F. So there you go, character 2. Then look, there's string 2. String 2 is ACE. So there you will see the character 2. After that, in the print statement, there's a full stop, and here you see the full stop here. Okay, so this is a, I tried to put all the data, the string and the char, the ampersand char and the string, sorry, the ampersand str and the string, to let you understand how this works here. So basically you cannot understand like the proper difference between string and string in this kind of examples, but when you go like dig deep into this, you'll just figure out how these differences work here. Okay, now added to this, there's another thing. What if you just erase this? Okay, what if you don't specify the ampersand before the string? Okay, so this might be like the thought you have. So to understand this, what if we just erase this and say it only a str? Okay, it says, I'll just bring it up. It says that it is expected an str type but found ampersand str. Look, this expected an str type but found ampersand str because the size of the value of the type str cannot be known at compilation time. So this is the error I told you. Like, you need to know the, like, the compiler need to know the size of the type str. Okay, the size of the value of type str, this should be known, like the length, the number of characters. So to know this, we need to just write ampersand str. Okay, we need to just write ampersand str. So this gives us the length of the like the, it says the size of the value of the type, like the size of the value. So it gives us the length of the string. So that should be known to the compiler at the compilation time. Okay, so that's the main error when you don't give it a str type. Okay, so up next we'll discuss about the tuples. So in these tuples, we would see first like what is tuple. So a tuple is like the grouping of the values of different data types. Okay, so different types collected into one compound value. So that's the tuple. So the individual values of the tuple are called elements. So we call it elements. That's the individual value of a tuple. And this the values are specified as a comma separated list, like the enclosed within a parenthesis. I will simply dig into the example to understand it better. Okay, so few things about the tuple. The tuple has a fixed length, which is equal to the number of elements in it. Okay, so after a tuple is declared, once like after you declare a tuple, you cannot increase its size or decrease its size. That is, it cannot grow or shrink in size. So element can't be added or removed from a tuple, and the data type of a tuple is defined by the sequence of data type in the elements, like sequence of data types of the elements. Okay, so let's see an example. So we say let we give it a name, say A, and we say A equals, and within this, simply write, like simply give a brackets and declare the tuple. Say we give it E. Okay, so that's the first element, separated by comma. Give another one, say 5i32, giving that the element is 5, the number is 5, and it's a signed integer, and it's a 32-bit integer. Then we say give it a true, like true false, this kind of boolean statement. And that's we declared an tuple of length 3. Okay, so in this you need to understand few things. The tuple length 3, but the tuple numbering, the element numbering starts with 0. So this is the 0th element, this is the first element. Okay, and this is the second element. So that's how we do this. And as said, it can have multiple data types. So the first the 0th element is of data type char, and the second element is I32. So integer type, signed bit 32. Okay, and then this is the type of bool. So basically, if I just try to say what this is basically a cat type, then followed by an I32 type, then followed by a bull type. Okay, so that's the stuff we did in this particular tuple named A. Okay, so the elements of the tuple, the elements in a tuple can be accessed by index position starting from 0. So we can do something like say print ln. Okay, so we're trying to print the elements of the tuple. Okay, so just give here a element, and you need to say a dot, uh, say you want to print the first one, so you need to say a dot 0. Okay, now if you just run it, see what happens. It will just print this element. Let it run. Look, the result is gives the first element. What if you just say a dot 1, like the second element? It should give you a 5 in return. Okay, so that's how it works. Then let me it just get executed. Okay, say that's the output we got, 5. What if we give a dot 2? This is give you a true. Okay, so that's the basic use. The tuples are useful when you want to combine different types into a single value. Like the function can use tuples to return multiple values, because tuples can hold any number of values, right? So whenever you are returning value from a function, then you can use tuples, okay, to return multiple values. So that's how this is done in like in Rust. Okay, so that is all for today's video, guys. In the next video, we will discuss about the if-else conditions, like the if-else conditional statements. Okay, how conditional statements are done in Rust. So we'll see those in the next video. So thank you for watching this video. Make sure you just like this video, share it with your friends, and also subscribe to my channel to see this kind of educational content continuously. Thank you all. See you soon in my next video.